Hi, this is Cindy Schwartz from Vassar College. Today we're going to work on a problem that involves conservation of momentum in two directions. And it's also going to involve a collision, which is going to be a completely inelastic collision, which means the objects stick together. So we have two balls of putty that are thrown as shown in the figure. The balls are on a frictionless table and they collide at point A. They stick together and they move on as one ball of putty. What we'd like to do is we'd like to find the magnitude and direction of the combined putty mass. Now, before we can do that, there's one more piece of information that we need, and that is what are the angles that these are coming in at. So the angle that this one is coming in at is going to be 30 degrees. And the angle that the other one is coming in at is going to be 60 degrees. Notice those are both measured with respect to the horizontal. Okay, so now we're going to find, for mass 1, the magnitude of its momentum, which is the product of its mass times its velocity, which gives us 3 times 5, which is 15. Now we need to find px and we need to find py. And px is going to be 15. Now, is that going to be the cosine or the sine of 30? What do you think? Well, if you thought it was the cosine, you were correct. And that leaves the y component to be the sine of 30 degrees. And we know in our heads, hopefully, that the sine of 30 degrees is a half. So this one is 7.5 kilogram meters per second. And the other one I did on the calculator, and that turned out to be about 13. And you notice they're both positive. Now we need to do the same thing for the other mass, the blue one. So we'll find the magnitude of its momentum, and that would be equal to the product of its mass times its velocity, which is 4 times 8, which is 32. And now we'll find px and py. And again, px is going to be the cosine of 60 degrees, and py is going to be the sine of 60 degrees. And when we put our numbers into the calculator, we get for px, we get 16, but what's really important here to notice is that it's negative 16 because the x component points in the negative direction, whereas the y component of this momentum points the positive direction, and it is equal to 27.7. So now we apply conservation of momentum. So over here, I'm going to calculate the initial momentum of the system. And we have to do that both separately for px and for py. So for px initial, for the total system, we add the two numbers together. It's 13 minus 16, which is negative 3. And for py initial, we add the numbers together. 7.5 plus 27.7, which is equal to, where's my y? 35.1. Now, because of conservation of momentum, we know that the final components have to be the same. So P, F, Y, so this is final. I'm doing it in brown because maybe the blue and red putty would combine to make brown. Probably not. So the final y momentum is equal to 35.1, and the final x momentum is equal to negative 3. So we can draw a vector that sort of represents that. It's not really going to be to scale, but it's going to look something like this. Okay. The magnitude of that final momentum is found by taking the square root of the sum of the squares of the components. I have no idea why I just changed to blue, but we'll go back to brown. And the magnitude of the momentum is about 35.2. And in order to get this angle here, theta, we'll use inverse tangent. So it's going to be the inverse tangent of the x component over the y component. Which turns out to be 4.9 degrees for theta. So I'll write that down here. We could go on and find the actual velocity of the glob by simply dividing its momentum by the total mass. We're not going to do that for this problem. So here's the brown glob of putty.